Not only does it add a new dimension to the tourist experience, but it could also be used to gain data on the tourist that visits that city. So what can AR do to Butuan City?
In our demo, in order to view the effect, the user has to click on the link or scan a QR code, which redirects them to Facebook or Instagram. Then you point your camera at the tracker, which is usually an image or an icon. Our demo leads you to a boat, and as you move your phone around, you can look around or zoom into various aspects of the model. These trackers can be placed in museums or around special places in the city so that tourists can scan it and get a sneak peek or small fun facts about the area and easily share it with their social network. It's not too late for the Philippines to make a dent in this industry. The number of AR users is projected to reach 2.4 billion by 2023, so don't blink or you'll miss it.
Our objectives were to clean, relevant, open data about agricultural disaster risk, combine it with geospatial data, and create an interactive web app. The end product was AgriHanda, a dashboard application that can generate choropleth maps, barangay data summaries, and custom charts.
For example, let us ask ourselves the question, in which barangays are crops highly vulnerable to flooding? We select agriculture, crops, flood, overall risk, and vulnerability score. The colors of the barangay change based on the score.
Drafting tool for making various kinds of charts using any of the variables in the dataset.
In summary, the app can be used by Butuan City government researchers to extract actionable insights about agricultural disaster risk, such as identifying barangays that must be prioritized for strengthening adaptive capacity.
Thank you for watching.
We are Electrum et Comunicado, presenting food production clustering analysis. Our proposal's main objective is to aid the food security challenges at Butuan City. We found a relationship between food production and clustering of barangays that is beneficial to their self-sufficiency and further development in their agricultural sector. Presented here is the clustering of each major commodity using the K-means algorithm. We chose 5 main commodities such as rice, corn, pork, chicken, and fish as our sample datasets since they are the ones available.
Is included on a different cluster depending on the commodity. The data presented shows the consumption versus the production in metric tons of each cluster. It can be inferred that 2 clusters have oversupply for 5 given commodities while 2 clusters have shortages.
Conclusion, the data of food production clustering analysis shows a potential basis and foundation for the development of food inventory management system.
The team is optimistic that there is still much room for improvement. That's why our team, Forge, decided to take on the theme of protecting and controlling forest ecosystems using data and technology. We want to augment existing good practices using data-driven solutions that are cost-effective and scalable. We employ the concept of Normalized Difference Vegetation Index or NDVI. This is a widely used indicator to quantify vegetation health based on how the vegetation responds to light at the near-infrared and red band from an area of interest. All available satellite images are extracted from the Google Earth Engine repository, and to implement this workflow, the team developed a prototype web dashboard, that is VegaMap. This app, the team envisions to provide not just insights but also oversight. Summing up, we hope that VegaMap as a tool can be a valuable option to generate valuable insights that can help the Butuan LGU.
Sometimes it's easier to solve the problems through data visualization. Visualization is the first step to make a solution to your problem, which is having a new dress right. What we did in our solution is simple. First, we need to have a shapefile or a map. We extracted it in the FieldGIS website, and then the next task there is to consolidate it or to merge it with the existing data in the hackathon, Excel files such as the resources and the hazards there. So once you click the ecosystem, you'll see the subcategories, which is either lowland, upland, urban, coastal, or rural. So with this kind of solution, we want to instill to the local government or the viewers or the users of this that there's a lot of avenues to improve. we want to extend it not just at barangay level or city level, Butuan level, but we hope that this kind of solution gives intuition for other regions until for the whole country.
And we present
FOREST, Forest Cover and Threats Monitoring System for Butuan City.
With this in mind, efficient and effective solution in monitoring the city's forest and forest land is a top priority.
Project Forestat is a web-based application which utilizes reliable information to present the forest health status of Butuan City.
This application can guide the LGUs in formulating its forest land use plan and monitor the compliance of its barangays and other stakeholders toward sustainable forest management.
With Forestat, our team expects that the user will better understand the relationships of the 4 key indicators.
With Google Earth Engine app, the user can be informed that the occurrences of forest loss started earlier on the yellow shaded area than the red shaded area.
Our team envisions developing a mobile application for crowdsourced data collection from the stakeholders of the forest.
With Forestat, we can make a greener future.
Likas Bahay, Bagong Buhay, finding suitable resettlement sites in Butuan City through data analytics. Our proposal is a data-driven decision support framework that can aid the Butuan City LGU in identifying barangays which are possible resettlement sites with these 2 considerations. Multisectoral analysis was used to quantify the suitability of solutions, to be able to compare them with one another based on 6 indicators, while genetic algorithm optimization was employed to systematically generate a set of solutions and then select one and improve on it in order to derive the best solution, thus showing a 49% reduction after the proposed relocations. The chosen criteria are on the factors identified by the end user. Should our team be given the opportunity to work with the Butuan City LGU and access to more relevant data, then we can enhance the framework to better consider the key factors and to reflect the actual situation in the city. This framework can be helpful to the Butuan City LGU to identify better solutions for our kababayans in Butuan City to have safer and more sustainable lives.
We propose a smart database software for predicting and visualizing the forest health of Butuan City, entitled Database Analytics of Habitats with Objective Numbers or Project DAON. Our system will store crucial information integral to determining forest health, including approximate values measuring biodiversity, air quality, pH level, and soil quality, and train a predictive model to gradually analyze these data and construct a value named the Forest Health Index. Our Forest Health Monitoring System aims to assist government officials from the DENR and other key stakeholders in assessing which forest habitats in the city require the most resources for conservation.
Will government agencies supply Project DAWN enough data to train the model with resources present and at their disposal, and will its benefits outweigh the marginal cost of money, time, and labor invested into worker training and system implementation? The answer to both of these questions is a resounding yes.
The hypothetical values of the Forest Health Index. Overall, forest monitoring and preservation is a niche concept in the Philippines that requires novel ideas for further growth and development.
We believe that one of the most significant hurdles preventing us from getting more and more people to Butuan is the hours upon hours, even days, that someone would spend to plan a trip to Butuan. The process of which only gets harder now due to the COVID restrictions and the lack of proper advertisement. Here to present Butuware, the ultimate Butuan travel buddy application. One version will be for the actual users or tourists, and another will be for businesses or establishments registered in the app. And lastly, a third version for LGU officials from the tourism sector. It has a featured section where we can promote and highlight lesser-known businesses and locations. The 2 main functions of the app here are also in the home screen. Let's try planning a trip by creating our own itinerary. Here, the different locations categories are displayed. When we choose one, it shows the different establishments under that category.
Going back to the home screen, let's try planning a trip by choosing from some pre-made itinerary packages. We can also have a look at the map of the city to see where our locations are. The way this app harnesses the power of data science is that it's able to track your preferences, like how many people you're bringing, what your budget is, what sites and places you frequently look at, and much more. With this, the app will create an itinerary that's made exactly to your tastes. We are confident that the implementation of Butuera will help Butuan tourism escape from the doldrums of this pandemic.
There are two crucial problems we deduced that we must solve. The first, that often gets overlooked, is the fact that a lot of people are simply caught unaware by disasters. The second, and most crucially, is the fact that there is a lack of communication that happens, especially during disasters. The LGU does not have access to a centralized system for disaster management. Laging Handa, a data-driven emergency app designed to guide you on what to do in the event of a natural disaster. One for the users and another for the administrators, who will aid in the management on the app. Our team values the accessibility of this app, which is why we included language options here in the settings. When we tap on one of them, we get two options. First, we have a survival guide on what to do in the event of a natural disaster. The app generates an optimized route for the user that leads to the nearest evacuation center. Using Dijkstra's algorithm and Geographic Information System Technology, or GIS, the app can dynamically calculate evacuation routes, taking into account things like elevation, risks of flooding, evacuation center availability, and more.